Okay, Math 095. I've had a few requests for this problem. It's the lifting force problem that is in section 7.6. And a couple people sent me this problem. So I'm going to do it on this video. I'm going to try to make it as easy as possible for you. So let's see. The lifting force F, I'm just going to underline, I'm going to go through and underline important things as I'm reading it through. Exerted on an airplane wing. Now it varies jointly as the area A of the wing surface and the square, so we're going to square this V, square of the plane's velocity V. The lifting force of a wing with an area of, so here's my area, 210 square feet, is, this is lifting force in pounds. When the plane is going 210 miles per hour. Well, that's our speed or velocity. Okay, so before we get to the second part, let's set up this formula. So we know varies jointly, okay? Means the formula is going to look something like this. So we're going to have our K and two variables. So this is kind of like a double varies directly. So we have y equals in any 7.6 problem there has to be a k, which is called the variation constant. So in any problem, any direct proportion, inversely proportion, varies jointly, we're going to have that k in there. So let me always have to have k. And then we've got the two variables here. So we know our lifting force F varies jointly. So I'm going to start writing this down. The lifting force F varies jointly, and there's going to be two variables sitting here, okay? Varies jointly as the area A and there's a times in there, So this is the lifting force, this is the area, varies jointly, and the square of the plane's velocity. So velocity just means speed. So square means we're going to square that. Put velocity or speed. So here is my formula that I want to use. Okay? Lifting force varies jointly as the area of the wing's surface and the square of the plane's velocity, which is just the speed. Okay, so that's the formula we're going to use, and now we're just going to plug in what we know. So the lifting force is 27,300 pounds. The lifting force is, okay, so I'm just going to plug that right in. K, we don't know. We have to find K. Okay, let's look for the area. Here it is here, with an area of 210 square feet. So I know A, I'm just replacing A with 210. And then I need my V and I need to square it. So what's my V? How fast is it going? The plane is going 210 miles per hour. So that's another 210 squared. Okay, so this is lifting force equals our constant K, which needs to be in there for any of these problems. Area is 210 square feet. And how fast is it going? 210 miles per hour. So we need to find the K first. Okay, so this is these are too big of numbers to just do by hand. I'm going to use my calculator. Okay, so I'm going to multiply these three, this first, I'm sorry, okay? And here's my calculator. Let's see if we can get a better picture. Okay, there we go. So I am going to take 210 times 210, and the squared is right here, x squared. That's a big number, 9,261,000. Whew, that's big. Okay, so I know 27,300 equals 9,261,000 times K. Okay, I want to solve for K. So how do I get K by itself? I'm just going to divide both sides by this 9 million. So I'm going to get probably a crappy looking decimal. Okay, I'm going to divide both sides by this 9,261,000. So I'm going to punch that in and get my K. Let's see what it is. So 27,300 divided by 9,261,000. Okay, and I get this really big decimal, but it says in the directions, leave K rounded to at least 5 decimal places. So 1, 2, 3, 4, 5. I want to look at the 4. If I go next door, it's a 7. So that means that I'm going to bump this up. Remember, we up it by 1. So my K is 0.00295 because I'm rounding it up. And that's rounded because the problem wants us to round it to 5 decimal places. Okay, so now we're on to the second part of the problem. So they say find the lifting force, so we're looking for the lifting force now, which is F. Okay. When the plane slows down to 120 miles an hour, so they're giving us a new velocity or speed. So we know V is now 120 miles per hour. Okay. So we're going to keep the area of 210 because they didn't say anything about that. So let's just start plugging in. Again, our formula, remember, is F equals, we know K now. K is 0.00295, and we're going to multiply that, whoops, sorry about that, times A times V squared. And here's our A and here's our V, and we're looking for F. Okay, so let's go ahead and plug these in. So force, this is my K that we found. My area is 210. And my velocity is now 120. And I'm going to square that. And again, I would just punch this all in the calculator, which you can do. So let's go ahead and do that. 0.00295 times 210 times 120, and here's the square button again. Okay, and this should give us our answer. Let's see what we get. I'm getting 8920.8. And in the problem, they want us to round to the nearest pound. So if I look over here and I want to round this up, I look next door, because I can't have 0.8. I can't have that as a final answer. I need it rounded to the nearest pound. So it's 8,920.8 pounds, but I need it rounded to a full pound. So if I look next door, remember 5 or better, hike it up 1. So here's my final answer, 8,921 pounds is the lifting force. So this is my final answer. So don't forget to round, and don't forget to follow the directions. And as long as you have the formula set up right, which if you go through and underline the most important things, you'll be fine. So let me know if that's good. And if you have any other problems with it, let me know.